Hello friends, welcome to Bindu Dhadwal chemistry lessons. Our topic for today is Mendeleev's periodic table. It was formulated by Russian chemist Dmitry Mendeleev in the year 1869. The characteristics of the periodic table are, you can see the periodic table is divided into 9 groups and 7 periods. The vertical rows are called the groups and the horizontal rows are called the periods. The 9 groups are indicated by Roman numerals 1, 2, 3, 4, 5, 6, 7, 8 and 0. The elements belonging to the first 7 groups are subdivided into subgroups. 2A, for example, 1A and 1B, 2A and 2B, 3A and 3B, and so on the basis of similarities in properties. The group 8 consists of 9 elements of 3 triads: iron, cobalt, nickel, ruthenium, rhodium, palladium, and osmium, iridium, platinum. The 0 group elements consist of elements belonging to inert gases or noble gases. These elements were discovered later on around the year 1898 by Ramsay and Rayleigh, and all these elements have a valency of 0. Hence they belong to 0 group. The elements are helium, neon, argon, krypton, xenon, and radon. There are 7 periods. They are numbered from 1 to 7. 4 will have 18 elements. Period number 5 will have 18 elements. Period number 6, of the 32 elements that it contains, 14 are placed in another series at the bottom of the periodic table. There are 2 such series of group 6 and of period 6 and 7. These are called Lanthanides and Actinides respectively. The periods contain different number of elements. The first period contains 2 elements. It is called the shortest period. Second and third have 8 elements each. These periods are called short periods. Group 4th and 5th have 18 elements each. These are called the long periods. Group number 6 has 32 elements in all, so it is called the longest period. And group number 7 is yet incomplete because a number of elements are yet to be filled. Importance of Mendeleev's periodic table. This table was the first attempt at classification which showed a systematic study of elements. Then, because of Mendeleev's periodic table, the prediction of new elements and their properties was possible. While framing the periodic table, Mendeleev laid more stress on similarity in properties rather than on increasing atomic masses of the elements. So whenever a particular element did not fit in the arrangement, he left a gap in the periodic table. So many gaps were left for elements which were still to be discovered. Because of Mendeleev's placements or of gaps, it was easier to discover new elements. So this was the importance. Correction of doubtful atomic masses. Mendeleev also corrected the wrongly calculated atomic masses of certain elements. For example, beryllium, on the basis of wrong calculation of having a valency of 3, was wrongly given the atomic mass 13.5. This is not its actual atomic mass, but just because its equivalent mass was 4.5 and they wrongly thought its valency was 3 and they multiplied 4.5 with 3 to give its atomic mass. But while placing the elements, the properties of beryllium resembled more of group 2 than its placement between carbon and nitrogen. So because of its resemblance, Mendeleev gave it a valency of 2 and computed its atomic mass to be 9, 4.5 into 2, 9, and rightly placed it in the second group. And similarly, he corrected the atomic mass of many other such elements. Then defects in the Mendeleev's periodic table. In the Mendeleev's periodic table, hydrogen was assigned a position in the alkali metals. All other elements are metals, whereas hydrogen is a non-metal. And then anomalous position of some elements like argon with the greater atomic mass is placed before potassium having lesser atomic mass because of resemblance of properties to the respective groups. Similarly, cobalt is placed before nickel even though it has a greater atomic mass. This was a defect. Then position of isotopes. As Mendeleev had arranged elements in order of increasing atomic masses, then isotopes of same element which have different masses should have been placed in different positions, but Mendeleev gave them the same position. Then no correlation of elements in subgroups. Like for example, this copper and potassium did not have any resemblance, but they were placed in the same group. Then different groups for similar elements. Copper and mercury have similar properties, but they are given different groups. Position of lanthanides and actinoids was also not correctly placed. They were placed at the bottom of the periodic table without assigning any proper reason why they are placed at the bottom. Then cause of periodicity, no proper explanation has been offered for the fact why the elements placed in a group show resemblance in their properties. This was found out later when modern periodic table was devised.